So, thank you, Paul. Thank you, ResMed, for hosting Red Hat. First question I have before I start, I just want to make sure that we're all on the same page. Do you guys know what Red Hat does in the Java space? I get some shakes in the head. I got nothing over there. Matt definitely knows. Some other people so from that standpoint, right? So why don't I talk just a little bit ahead to about what Red Hat actually does in the Java space, and then I'll quickly transition that to OpenShift, and I'll tell you why we got into OpenShift, why is an open source company big in that space. We also have a demo, and we'll also talk about a little bit about the other components that make up the Docker solution that we have. So I'm going to skip slides. I'm not going to go and bother with that. But I really wanted you to see this slide. So as you kind of imagine, is that Red Hat has actually evolved in the Java space pretty big. We're the primary sponsor for OpenJDK. Which is essentially the engine that eventually becomes to the Sun JDK too, right? Some of those pieces. We sponsor more than just Java. We have Ruby on Rails committers. We have PHP, Python, R, you name it across the board. Not all of our projects, though, that we commercialize, right? So our goal here at Red Hat is to sponsor projects out of the community. What we do is we interview our customers, and we actually create community-based projects that solve business needs, right? So we take multiple components here, and we package them up into the community. And eventually what we do is we commercialize those open source packages themselves. So I'll take a case in point. Let's talk about the top one here, Wildfly. Wildfly is our community Java EE server. From that standpoint. Right now it is actually nearly completed to be commercialized. And the outcome of that is Red Hat JBoss EAP. Right now 7.0 is in alpha. So how we name the moniker is EAP 7 maps the Java EE spec 7. EAP 6 maps the Java EE 6 spec, right? And EAP 5 to the Java EE 5 spec, right? So what do we do between these two products? So between the last version of EAP and the community version is that what happens is that every 6 months or 3 years we take a cut of the code and we make a commercial version out of that. The last release of EAP 6 had between community and enterprise was about 352 patches was done between the community and the enterprise version. And a lot of that was to do with because the community has a smaller test matrix, it has a smaller QA environment, and the EAP version actually has a test matrix of about 60 different products like Oracle RAD, different versions of different enterprise vendor software, right? And that's what we kind of sell to customers, right? The other thing too with community is what we do a lot of our development spikes. So you'll see us play around with it. One of the newest features, just to talk a little bit about Docker itself, EAP 7 has this new feature called a offline CLI. So in the old world, what happened is that if you start up a Java app server, you'd have to wait for the administration server to come on up, and then you can execute commands to configure it. EAP 7, because of Docker, was one of the use cases. You can actually do all the configurations of JBoss EAP and then turn it on afterwards, right? So you don't have to write this like wait 40 seconds, wait a minute for the server to start up. You never even know, and then you execute the rest of the commands. So that's one of the enhancements that we did in the product itself. Now across the board, you can kind of see Tomcat, we have the first version of JBoss EAP. Infospan is, I'm not sure if you guys know, is Databricks. Have you guys worked with a lot of Databricks products, right? So our product here It's a key value store. It's an object cache. It's also a MapReduce, and it is also a NoSQL solution. And you can go, obviously, to use the community version, and you get all those features. We also come with a monitoring product. The new version that we're building on out because of Docker itself is that the older monitoring solutions are agent-based, right? So they monitor the operating system and the applications on top of it. But in the new world where you have Docker containers are ephemeral, right? They can move to one server, to another server. But if you have an OS monitoring agent, you're monitoring a system that the app may not be on it anymore. So we had to move to an agentless model, right? And we have to be able to follow the Docker container or follow the application as the Docker container moves from that standpoint. Other people have said it's kind of like New Relic and App Dynamics, but not as extensive. It's not a full APM suite. It's agentless monitoring, but the goal is to have a pretty extensive way for you to monitor applications, regardless of where it sits. Camel, really popular in the integration world as an ESB. It comes in two formats. You can get it as a jar, or you can get it as a client-server mode, right? It has over 150 adapters to things like Salesforce, SAP, HANA. It also has like integrations to things like Spark, Kafka, and a lot of the other traditional systems that you see. ActiveMQ, or Red Hat AMQ, that's message delivery from that standpoint. Data virtualization. Anybody here use data virtualization? No? So what it does is it makes multiple data resources look like a single database. So imagine you have this Teradata data warehouse, you have an MDM system, you have a Hadoop system, you have MySQL behind the scenes, and you want to present that as one single virtual database to something like Tableau or some type of mobile client, right? So that provides you that aggregated view or federated view of the system itself. You can do masking, you can do a lot of other stuff from that standpoint. We also have a rules engine from JBoss itself. It does is either freak algorithm. Not sure if you guys know freak algorithm. Anyways, it's a way for you to go and execute rules. It also has a component in there to do any incomplete problems like traveling salesman or resource management type of problems, right? So it's a way for you to go and execute rules across the system. And then we also have a BPM product, which is a full-blown BPEL2 server from that standpoint. So this is just a quick snapshot of some of the things that we do from Red Hat in terms of the Java space. I also have my colleague here, John. I'm not sure if you met him, but John is our product manager for microservices strategy at Red Hat from a PM level, right? Product manager level, right? But if you have any questions about some of these products, right, definitely John or myself can go and talk about it. All right, so that's I think that's pretty good in terms of our general overview of product. So before we go to the rest of our conversation today, how much do you guys know about Docker? You guys know? Okay, I get nods. Like, you're the second nod from that standpoint. How are those guys over there? Okay, you guys, nothing.
I've heard of it.
Kinda. Okay, we get kind of all over the place, right? All right. So, you know, when containers came on out, right? People were asked about what's the value of a container, right? So I'm going to start that before I go to the rest of my presentation, right? So in the VM-based world, say for instance you have a 100-node web server, right? You have a hypervisor, you have 100 OS installations, you have 100 monitoring agents, you have 100 versions of the application. You know, you have that full entire stack that's running on the environment, right? In the new world, what you have is one OS and 100 Docker containers. So just imagine what the implications of that means, right? One of the implications is that you don't have is the OS overhead of those 100 machines, right? They're just keeping the lights on, right? Making sure the clock runs, making sure that all the stuff in your operating system that's just the 20%, 15%, all that goes away. So a lot of people are moving to Docker because of application density, right? I don't have that OS overhead. That's one. The other thing that a lot of people are moving on to Docker is reasons around is a little bit to do with, I just had a brain fart, sorry about that. A little bit to do with DR and application provisioning, right? So one thing about Docker containers is this concept of immutability. So what happens if you've seen the whole build process of the build chain for Docker, you get an application, you install it in a container, right? And at the very end of the output is this thing called a Docker image, which is basically a binary file. Just think of it as kind of like a ./ file or exe from that point of view, right? Well, the nice thing about having is a single exe, right? You can do an MD5 hash on that file, and that's the exact same version of the code that's running in dev, UAT, staging, production, right? There's no more chat about, is this the same version of the code, same version of the binary that's moving across environments? No, it's exactly the same, right? We'll go to it a little bit later about how you can tell the differences between Docker running in different environments. But think of it from that standpoint, right? I have a single image, the promised land of like, nobody from dev says, this is not the installation that we have in dev, all these config files are different in UAT, staging because it's, bigger from that standpoint is totally different than all our dev environments. All that flies out the window, right? Single installation that's used across the board. Talking a little bit also about is the DR from that standpoint, right? A lot of times from a DR situation, it's not the same application version that's deployed. It's really tough for you to go and deploy the exact same thing. Well, in the new world, what happens is the application and the data is disjointed in Docker, right? So what happens is typically Docker is what they, like I mentioned, is ephemeral. If you kill the process, everything you've done inside the Docker container actually disappears. In the new world, with Docker, in the enhanced version of Docker, is that there's this idea of persistent storage. So what happens is that you have your Docker image, you attach this persistent storage to it, and you write everything on the file system, whatever you want to go and write. If you lose the Docker container, what happens is another Docker container gets provisioned, and persistent storage gets remounted, and you're back up and running, right? If you think about it in a DR situation, look at it. You don't have to go DR the OS, the VMs, the data, all of the application tiers from that standpoint. All you have to do is just DR the data. Everything else, those binary EXEs, are already pre-staged at your DR facility or wherever data centers that you have, right? Imagine how much data that you've cut down, and imagine how much time how much it takes for you to go and bring that environment on up. So those are just a few of the things. I'll go in deeper detail about all the various pieces, but just keep that in mind. Right? So, since most of you guys, I think, know a lot of existing solutions on out today, right? I'm going to skip some of the opening video because we're all tech guys. Sometimes I have to put a video together just to talk about the product in an abstract fashion. So OpenShift, from that standpoint, is think about it as a data center in a box, right? So what we did is at Red Hat, we have several different ways for you to consume Docker containers. So you can go and buy RHEL, Red Hat Linux operating system, and we provide is Docker there. Right? And that's like, great, I have my own Docker runtime, I can get support for it, I can get fixes and whatnot, right? But if anybody knows, if running Docker containers, is that it's easy to run one single instance or on one single machine. The harder problem is how do you orchestrate and manage 100 different Docker containers spread around 20 different servers, right? The management aspects is which was really tough. And as developers, our biggest problem too is how do we not just go and provision the Docker containers, but how do we get our source code into the system and build the image and have that deployed and have the CI/CD process actually go and kick off, right? This is the much more tougher picture. So what Red Hat did was that we interviewed a whole bunch of customers and we said, what is the best practices for CI/CD? What's the best practices for you to push out code into production environments? What's the best way for you to go and just do application development, period, and full stop, right? And so OpenShift was our solution to go and achieve this. So that's why I'm kind of saying we have a great solution. You can just buy RHEL and you glue Docker and you do it all yourself, or you can do from top down, which is OpenShift, and it essentially does all this automation, integration, CI/CD out of the box. The other thing that we actually saw out in the marketplace, right, is just the things that you see at the very bottom of this chart, right? You guys get it, right? DevOps really changed the way that companies are really building and deploying applications. Microservices is the new hotness. I would also say, and I've got another slide about it, is how many of you guys have ever heard of 12-factor applications? Ooh, very cool, right? So 12-factor application is the new hotness, right, along with microservices. I'll talk a little bit more about 12-factor, but basically those two is consolidating to what is now the new cloud-native architecture. Think of it as the new end-tier architecture redefined. How do you scale to massive Google, LinkedIn, Facebook levels as an application developer? All right. Containers, because of the application density and some of the other things, and everybody wants to run is a hybrid environment, whether that's on-premise or connected and bursting on out or load balancing with something like AWS. So just also to level set, what's the difference? A lot of people ask us the difference between some of our other products. Like we have OpenStack. How many people here have heard of OpenStack? Oh, all right, that's pretty good. All right, so you guys know that it is basically Amazon AWS equivalent, right? EC2, you get an EC2 provision, whatnot, right? So that's really you get the fact to the OS in it, right? And a PaaS is supposed to go do more than just give you an operating system. It's supposed to go and install applications for you, and it's supposed to give you a CI/CD system along with source control. That's the way that we define PaaS today. And the original author, or the guys who originally thought of the PaaS itself, is going to say, as a developer, give me a 100-node cluster that's based off of Java. How you guys on the ops team provision this out, where it is around the world, how storage is attached, all those other questions, I don't really care. All I care about is I ask for what the ideal architecture end state of the environment is, and you give me a Git repository or a Git URL, and if somehow I push code into this Git repository, it federates out to 100 containers, right? That's the promise that a PaaS is trying to go and solve, right? Instead of you getting an OS and then you've got to have a middleware admin, all these other guys who come on in and you have to wait another 2-3 weeks for the rest of the environment to be built on top of you, right? It's trying to get skipping all the way to the end. The other thing that I will mention about is 12-factor itself. So this 12-factor, like I mentioned, is the new hotness, and John can also talk about microservices from that standpoint. 12-factor is actually broken down, 12-factor.net, into 12 things or philosophies that an application should be built with. If you build to these principles, the idea here is that you have a truly internet scalable application, right? There's some pieces in it that's really interesting. So one of the things that talks about is immutability. right? How can we make sure that the same piece of code is used in dev, to UAT, to staging, production? That's interesting. Environment parity from that standpoint. How do we go and have a declarative model for everything that we build? Make each tier, the web tier, as stateless as possible, and using backing services like either data grids or database to hold state information. Because once you move to a more stateless web model, web tier model, or even an ESB model, what's interesting about it is now you have no coupling for you to be able to move from a single node to thousands of nodes from that standpoint, whether they are geographically distributed or not. All right. We can talk about that a little bit more, but 12-factor, new hotness, you'll hear more about it in the next couple of years from that standpoint. So at the very end of the day, we said, okay, we interviewed all our customers, we said, what would the ideal solution would be, right? So the big things that everybody asked us, they said they like things like self-service. So give us a self-service dashboard with a service catalog that can ask is, here are the different types of application architectures that I want to go and have. The second thing they asked about was that no single organization would have one single language. Right? So we have to support Polyglot. You'll see in the demo that I'll have things like not only we support Java, PHP, Python, R, a mean stack, Node.js stack, right? Run them all as equal members to the system itself, right? And from the standpoint of automation is be able to go and automate all the pieces from getting from source code all the way to production, right? If you can go and do that as much as possible. All right. So that's what OpenShift is about. All right. I'll skip over to architecture if nobody has any questions. I don't see any questions. Looks like we're good. All right. So OpenShift is actually built off of RHEL. So RHEL is the operating system. So we run wherever RHEL will run. So RHEL is currently certified on Azure, AWS. It can also run on SoftLayer, DigitalOcean, your own data center. Wherever RHEL will run, we can go run, right? The two pieces that make up OpenShift is really the nodes themselves. And the nodes are really places where the application can sit on, right? And fundamentally, what we picked for our node component was Docker itself. Now, I'm not sure if you guys know, Red Hat is the second largest contributor, or the largest contributor of Docker source code other than Docker themselves. We actually worked with Docker when it was just a 10-person company. Now they're about 200 plus, which is kind of interesting in itself from that standpoint. Docker is an API. So what that means is that it's an easy way for you to go and do lifecycle management for provisioning out applications to currently the Linux infrastructure, but they're trying to expand a little bit more. The reason why Red Hat has so many developers on Docker itself is because Docker didn't really build that much new stuff. They package current items in a more easily digestible fashion. So here's one of the things that for example, if you run is Docker itself, right? If you've ever run it locally on your machine, security-wise, it says run as non-root. So we don't think that's a great idea, Red Hat. We said, like, what you should go run is containers around SC Linux, right? And SC Linux is the NSA version, hardening, security model. It's a kernel-level way for you to go and do isolation. So what we did was we modified Docker to run on SC Linux. That's one aspect. The other thing is Docker itself didn't have is originally storage, right? It was all ephemeral, right? So right in the container itself, and it would just blow away. So because we actually have another product, Red Hat Virtualization, we ported the storage mechanism, and Red Hat Virtualization is basically EXI or Microsoft Hyper-V, right? So we move that type of code into Docker itself so that way we can go and attach storage and deattach storage as we see fit on the Docker container, right? The other thing that we also did from that standpoint was things around even networking. So networking, if you've ever run Docker on your own machine, it will actually, if you run 10 instances, it will inherit the networking host operations, right? So if you're running 10 containers, all 10 applications, if each container contained a different application, would see each other, right? And that's a no-no in the enterprise world, right? So what we did was that we actually modified it so that it would run, each container would have its own IP address, and each application would be in its own VLAN, right? So maybe images 2, 4, and 6 can see each other because it's own VLAN. 1 is isolated, 3 is isolated, right? 7 and 9 is also within another different VLAN, right? So these are some of the things that we did to Docker itself and also into the OpenShift product. The next piece we have, and the final piece, is really the intelligence, which is Broker. The Broker is an orchestration piece of technology, and this is where most of the secret sauce actually happens. It's a way for us to be able to manage the environment. So we talk, the application developers, or the people who use the system, talk to the broker, and they say, give me a 100-node web server. Give me, blah, blah, blah. If any of the nodes die or any of the containers die, right, re-provision up to what the policy says, right? So if you move 5 containers, it will provision 5 containers from that standpoint. Heritage-wise, what we did was that when we originally did the container technology, we went out to the open source world to explore what was available. If you're familiar with Docker, Docker has their own orchestration technology called Docker Swarm, right? At the time, it was only 6 months old. We said, who are your customers? What use cases have you done? And that wasn't that promising. Then we went to another organization called Mesos, Apache Mesos. It was originally the orchestration technology for Airbnb, open source 2-3 years ago, primarily focused with Hadoop and Yarn workloads, but able to modify to work with even Docker containers themselves. We said, that's great, that's interesting, let's keep on talking. So the last place that Red Hat visited was a company by the name of Google. And they have their own data center technology called Google Borg. That's how they run their own data centers. And we said, would you be willing to open source the most reusable bits of your orchestration technology and open source it? They said that was interesting. It took us about almost close to a year, but we were able to work with Google partnership and be able to open source that. And that is called Kubernetes. And if you're familiar also with some of the story, a Docker is a whale, right? A ship, a container, right? Kubernetes is Greek for captain. You get it? A lot of open source people, really funny, right? Also, the main developer of Kubernetes was a sailor too, right? So that's why he named it from that standpoint. So now that you know Kubernetes, Kubernetes is the brains driving the ship, and then you've got your containers that are up on the system itself. Okay. Also, a little bit about how we break up the individual environment itself. We actually, you have is the Red Hat Linux runtime on the very, very bottom. And then what happens is that there are Docker images that are provisioned inside of each of the containers, right? And you can actually set the different sizes. So they'll do things like C groups in Linux, which is a way for you to go and bound CPU utilization and also memory and some of the other stuff. But there's also some other interesting aspects in order for us to kind of lock that. There's more detail. I actually brought out, and if you can kind of go see it, maybe pick it up in the break. It's a coloring book it's the container coloring book. And in it, it talks about the story about what is the difference between a container and a VM, and it talks about the security model, it talks about namespaces, it talks about, but in a very funny way, right? So you guys might want to check this out a little bit afterwards, right? And I also have O'Reilly book that we wrote, and it's for free for members, and I can give Paul the link to it, but it talks to specifics about what it means to run Docker at scale in terms of security, because that's typically the #1 reason why people come and talk with us. It's not to say Docker is easy to run, but how do you make sure that it's secure? Any questions?
Yeah, I have one question.
Yep.
Ubuntu is in the same space. I believe they support OpenShift as well. They have Juju for orchestration.
Yes.
Can you compare that one with the solution for Red Hat?
I'm actually not familiar with Juju itself, right, from that standpoint. But what we do know from that is that Kubernetes, along with Kubernetes, we're the largest contributor of source code other than Google themselves, and there's about 500 committers on that project. And Docker has about 1,000 committers, and we actually, as of right now, we have more employees than Docker writing on the source code. Although quantity of code-wise, Docker has more. If you go to Stack Analytics, they'll actually go and measure on out based on email IDs which company is doing what pieces from that standpoint. We also think, because what's unique about the environment too is because one slide I didn't show you, what we think there's a little bit different, is that Red Hat has not just the operating system, but we also have is the storage layer, right, with Red Hat storage. We have also, in the OpenShift product, we also have our own SDN in there, right? So we have committers. Basically what happens in the open source world, so not just that, we also have middleware products from JBoss Suite. We also have all these other pieces. But the basic gist is that the open source code base moves so fast. So the problem is like, when you get as a problem, does that company really have a committer for fixing that problem, right? So, case in point, I'm not going to say Ubuntu because I don't know how much size of the company is, but if you look at SUSE has 850 employees. Red Hat has 9,000, right? That's the difference if you want to have something fixed from that standpoint. So I'm going to go into, any more questions before I go into the demo? No? Any questions about what's happening? All right. So we're making good on time. You guys are easy. You guys haven't asked me any tough questions yet. I was expecting you guys to throw me something like that, or somebody throw me some stuff, right? You'll save it. You'll save it. Save it from that standpoint, right? So I'm going to go and show you the developer workflow, right? So the developer workflow here is that really it's 5 easy steps. You've got a portion of it that you go and do the configuration of the application itself, right? And then you'll go and we'll have you show you is a way for you to go push the code into the environment and then make a quick change to the application. And then you can see it provision on out into the environment. And then we'll see this last piece is the scalability aspect, right? So that's the general workflow, day in the life of the developer from that standpoint. So the first piece is the configure aspect, right? So we have our own service catalog, right? And basically it's a registry of Docker images at the very end of the day. There's also some other metadata that's related to the Docker image itself. You also have networking parameters, storage parameters, all that type of stuff, right? That would need in order to build the product itself. All right. So I'm going to go through my environment here. So I already logged into the console itself, right? I'm going to just go pick. I'm going to go add project. So here we talk about the service catalog. Right? The service catalog has a whole bunch of applications that's already put into the environment. Right? You can go and click on Show Templates. So here's a Node.js example with MongoDB, AMQ. You've got EAP. You've got Jenkins, you got Tomcat, you got different databases, right? If the application can be Dockerized, right, it can show up in here. And all these things right here are configuration files that are defined by JSON, right? So it's really easy for you to go and set that on up, and you choose however which way it is. So we're going to pick as Ticket Monster, because Ticket Monster is the default EAP application. So when you ever buy JBoss EAP, our app server, Ticket Monster is the first thing that most people install. And basically, it's a Java EE application that allows you to buy tickets at an event. In this particular project, what it's been defined is that it's going to use this JBoss EAP. It's going to have this, the monster application from source code, right? And there's going to be a MySQL instance. And so these are some of the parameters that you can go and configure. Now what happens is when I click on next, right, it says, great, you know, all the applications configured, right? Let's go and whoa. Wait 1 second here. So what happens is that let's start as a build. So if we go back, you'll see this console, and what's happening here is that I provisioned out the application. It's already predefined in it as a gig URL. It's taking that source code and actually building as a Docker image right now. And once it's finished building the Docker image, you can actually go and see the container start up. So just for fun, let's actually see behind the scenes. Before the build, we already finished the build before it actually showed on up. So what happens is, I was too slow to catch it actually going through the build process. So right now what you've seen is that there's one pod that's running, so one container that's running. And here's the Docker image, and it also has a second Docker image which contains the MySQL server. And if I right click here, seems like I have a problem here for starting it on up. But,
You'd add,
huh?
you'd add 4880 in there?
No, it's actually, it actually should start up just fine. All right, we're going to have.
Take a break.
Yes, let me take a break from that standpoint. Ideally, what would happen is that application would have shown on up. So if you don't mind, give me 5 minutes for me to me to check this on out. I appreciate your time.
Okay, let's go ahead and take 10 minutes for the toilet break and get some more pizza. And of course, buy tickets for these lovely t-shirts.